Kami po ang Group 4 at ang topic po namin ay about sa Introduction to Travel and Demand Forecasting, the classic 4-step of forecasting model. So when we say travel demand forecasting, ito yung proseso na ginagamit para ma-predict yung travel behavior at yung resulta sa demand for a specific future time frame based sa assumption dealing with land use, the number and the character of trip makers, and the nature of the transportation system. Isa pa, when we say travel demand and forecasting, isa to sa key component para sa transportation engineer, kung saan ito yung nag-aalaw ng engineer para ma-predict yung volume ng traffic na magagamit sa given transportation element in the future, whether that element is an existing highway or a potential light rail route. So ito rin yung transport demand forecasting din kasi ay nagagamit siya sa important basic data para ma-evaluate yung efficiency and transport of facility supply and transport policy such as road construction, public transport introduction, and transport demand management implementation. So may apat na classic forecasting model. So yung apat na klase ng or 4-step forecasting model o yung tinatawag na natin na classic 4-step forecasting model, ito yung una, trip generation, trip distribution, model split, and route or traffic assignment.
Trip generation. Trip generation is the process of determining the number of trips that will begin or end. So, ito yung first step in the classic 4-step of forecasting model. It predicts the number of trips in each zone. Classification of trips based on trip purpose. First is home-based trips. So, ang trip ends niya is sa home. For example, home to work, work to home. Next is yung non-home-based trips. So, kabaliktaran naman to ng home-based trips. Hindi siya mag-e-end sa home. For example, work to shop, shop to work. Classification of trips based on time of day. Trips are often classified into peak and off-peak periods. Proportion of trips by different purposes usually varies greatly with time of day. So, for example, 52.12% of workers is pumapasok sila during AM peak, while 14.68% naman during night. So, ibig sabihin, mas maraming na produce na trips tuwing umaga or AM peak. Classification of trips based on socio-economics. Trips may be classified by income level, car ownership, and household size. Factors influencing trip reduction. Number of workers in household, number of student, household size, the household income, and the number of cars. So, yung trip reduction, residential land use ang nagpo-produce ng trip ends. So, if marami kayong workers or students sa inyong house, so ibig sabihin, mas maraming trip yung na-produce. Next is the factors influencing trip attraction. The floor area and number of employment opportunities in retail, trade, service offices, manufacturing, and wholesale areas. School and college enrollment, other activity center like transport terminal. So, sa trip attraction, non-residential land use ang nagpo-produce ng trip ends, kasulad na lang ng school, mga transport terminal, and offices. Analytical tools used for trip generation modeling are the regression model and the cross-classification. Regression analysis is a set of statistical method used for the estimation of relationship between dependent and one or more independent variable. So, independent variables are the factors that you are trying to predict, while the independent variable is yung factors na nakaka-apekto sa dependent variable. Regression analysis includes linear, multiple linear, and nonlinear. So, most common na ginagamit yung simple linear and multiple linear. Kasi yung nonlinear is ginagamit lang siya sa more complicated set of data. Next is the regression analysis, simple linear regression. So, simple linear model is expressed by y is equal to a plus bx plus e. Y is the dependent variable, x is the independent, a is the intercept, b is the slope, and e is the residual or the error. Multiple linear regression. So, the mathematical representation of multiple linear regression is y is equal to a plus bx sub 1 plus cx sub 2 plus dx sub 3 plus e. Y is the dependent variable, x sub 1, x sub 2, and x sub 3 is the independent variable, a is the intercept, b, c, d is the slope, and e is the residual or error. Next is the cross classification. So, this is the technique developed by the Federal Highway Administration to determine the number of trips that begin or end. So, two variables are commonly used, the average income and the car ownership. And dagdag pa doon is ginagamit din nila yung household size. So, cross classification, example of developing trip generation curve from household data. So, sa table na to is pinapakita yung number of trips per day and the annual income and the car ownership. So, step number 1, produce a matrix that shows the number and percentage of household as a function of auto ownership and income grouping. So, yung table is nire-represent niya yung income level and car ownership, and yung number na may parenthesis is yung the observed income level. Step number 2, produce a matrix shows the average number of trips per household versus income and car owned. Step number 3, determine the percentage of trip by each trip purpose for each income category. So, ilalagay mo dito yung all the percentage of home-based and non-home-based trips.
Trip distribution. Trip distribution is the second component in the traditional four-step transportation planning or forecasting model. This step matches trip makers' origins and destination to develop trip table. Ano nga ba yung trip table? Yung trip table is a matrix that displays the number of trips going from each origin to its destination. Trip distribution step is going to be started by introducing an origin-destination matrix for all the zones. Historically, this component has been the least developed component of the transportation planning model. Work trip distribution is the way that travel demand models understand how people take jobs. There are trip distribution models for other activities such as the choice of location for grocery shopping, which follow the same structure. In table number 5, for example, here total trip production is 9,344,120 and total trip attraction of 12,879,969, which is greater than the trip productions. But total trip attraction or destinations must be equal to total trip productions, as trip productions is considered to be exact. For this reason, the trip attraction for different zones is multiplied by an adjustment factor. The factor can be stated as adjustment factor is equal to total production all over total attraction, equals 0.73. Adjusted trip attraction, total production all over total attraction times the trip attractions of any zone. This process generates table 6. Transport network link impedance or resistance to flow. The difficulty of moving from one node to another in a network is the link impedance. Impedance in electrical terms means total resistance. and for transport, the meaning is the same. For modeling link impedance, can be expressed as distance, but travel time or apparent costs are usually better measures. Arbitrary units that are functions of impedance factors may be more convenient than actual measurable quantities for modeling purposes. Such factors can be determined by calibration of some distribution function, such as a gravity model with a known distribution pattern obtained from an origin-destination survey. It is essential to the modeling process to obtain the best practical measures of impedance. This is usually done by testing model output against historical information for the same situation. The measures of impedance which give the closest match are used. The measures may be different for different transport activities.
Table 7, Cost Matrix Table or CIJ in terms of time. Using the following formula, impedance is calculated at Table 8. Impedance factor equals E raised to negative B CIJ, where dispersion parameter measuring sensitivity to cos B or beta is 0.1, which is assumed, and C sub ij equals the general cost of travel time between zone I to zone J. Table 8. Impedance factor values. Now, summation of impedance factor equals to 22.1239 and total trip of 9,344,120. Another factor is calculated for the distribution of trips among the zones. That factor is equal to total trip over total impedance factor, which is 422,354. Now, trip for each zone, the different zones using the following formula is calculated. Trip of any zone equals to total trip over total impedance factor. Impedance factor for this particular zone only. Finally, trip distribution from one to different zone is found at Table 9, which is the trip distribution after 10 years for different zones. Now, for the table number 9, trip distribution after 10 years for different zones. From table 6 and table 9, it is found that there are huge differences in the trip productions and trip attractions than what it should be. Although it is found that total trips are same, but there are differences in the total production and attraction into different zones. It means the interzonal distribution is not correct. For this purpose iteration, by using a program of Microsoft Visual C++, to solve the problem is held by Appendix H of supplementary file. After using this program, the adjusted trips from the different zones are found. This is the final origin destination matrix for trip distribution among different zones after 10 years, which is shown at the table 10 with adjusted trip distribution after 10 years for different zones.
4.3 Modal split. Modal split, the varying proportion of different transport modes which may be used at any one time. The choices of modes may be determined by the cost, destination, capacity, and frequency of the models together with the nature of goods carried and their destinations. Yung modal split, ito yung percentage ng travelers na gumagamit ng particular na mode of transportation. Nakadepende sa may cost and sa destination nila kung ano yung gagamitin nilang mode of transportation. Mode of choice. The choice of transport mode is probably one of the most important classic mode of transporting plan. This is because of the key role played by the public transport in policy making. Public transport mode make use of road space more efficiently than private transport. They also have more social benefits, like if more people begin to use public transport, there will be less congestion on roads and the accident will be less. Mode of choice. Yung mode of choice, isa to sa importanteng mode of transportation planning kasi dito na determine kung ano yung pwedeng gamiting mode of transportation. Dito sa mode of choice, mas efficient yung public transportation kasi mas marami siyang isasakay, so mas luluwag yung kalsada kasi onti lang yung gagamit nito kung yung mga may sariling sasakyan ay gagamit ng public transportation. Sa private transportation naman, mas siya flexible kasi sarili mo yung sasakyan and komportable ka sa biyahe. Factors influencing the mode of choice. Number 1. Characteristics of the trip maker. The following features are found to be important. Letter A. Car availability and ownership. Letter B. Possession of a driving license. Letter C. Household structure. Letter D. Income. Letter E. Decisions made elsewhere. Number 2. Characteristic of the journey. Mode of choice strongly influenced by letter A. The trip purposes. Letter B. Time of the day when the journey is undertaken. Letter C. Late trips are more difficult to accommodate by the public transport. Factors influencing the choice of mode. Letter A is car availability and ownership. Siyempre, kung yung gagamitin mo na sasakyan is hindi available or gagamitin ng may-ari, makaka-apekto talaga ito sa choice of mode mo. Letter B is possession of a driving license. Siyempre, alam naman nating lahat na hindi tayo pwedeng mag-drive ng walang lisensya. Letter C is household structure. So, dito naman kunwari may dalawa kayong anak and yung sasakyan nyo is single. So, hindi kayo kasya doon. Makaka-apekto talaga ito sa choice of mode nyo. Letter D is income. So, income naman is kunwari may pupuntahan kayong lugar and mas makakatipid kayo kung yung isang mode ng transportation yung gagamitin nyo. Kunwari public. So, yun yung pipiliin nyo. Letter E. Decision made elsewhere. For example, the need to use a car to or take children to school. So, pag ganito, nagsasabay yung paggamit ng sasakyan, nakaka-apekto to kung ano na lang na mode ng transportation yung gagamitin mo. Number 2. Characteristic of the journey. Letter A is the trip purposes. Siyempre, nagiging factor din yung trip purposes natin sa choice of mode natin. Siyempre, kunwari, yung purpose ng trip natin na yun is may kukunin tayong isang malaking bagay. Siyempre, pipiliin natin yung mode of transportation na kaya-handlein yung kukunin natin na yun. Letter B is time of the day when the journey is undertaken. So, nagiging factor to pag yung mode of transportation natin is 1. Public. Letter C is late trips are more difficult to accommodate by public transport. Yun nga kasi yung public transport meron silang tinatawag na yung last trip pag gabi na. So pag late na yung trips niya, mahirap na talaga may accommodate ng public transportation yan. Type of modal split models. Number 1. Trip and modal split models. Traditionally, the objective of the transportation planning was to forecast the growth in demand for car trips so that the investment could be planned to meet the demand. When the personal characteristics were thought to be the most important determinants of mode choice, attempts were made to apply modal split models immediately after trip generation, such as model is called trip and modal split model. So yung trip models na to is accurate siya sa mga short run and kapag available yung public transport sa isang area. Number 2. Trip interchange modal split model. This is the post-distribution model. That is, modal split is applied after the distribution stage. This has advantage that it is possible to include the characteristic of the journey and that of the alternative modes available to undertake them. It is possible to include policy decision. This is beneficial for long-term modeling. Trip interchange modal split models. Kung yung kanina is accurate siya for short-term run, ito naman is beneficial for long-term modeling. Yung isang limitation lang ng model na to is nagagamit lang siya for matrices ng mga traveler na isa lang yung choice na available. Number 3. Aggregate and disaggregate models. Mode of choice could be aggregate if they are based on zonal and interzonal information. They can be called disaggregate if they are based on household or individual data. Yung aggregate, ito yung pag-compile and pag-summarize ng data. Yung disaggregate naman, ito yung pag-breakdown ng data.
Traffic assignment. Final step in the transportation forecasting process is to determine the actual street and highway routes that will be used and the number of automobile and buses that can be expected on each highway segment. The procedure used to determine the expected traffic volumes is known as traffic assignment. Since the numbers of trips by transit and auto will travel between zones are known from the previous step in the process, each trip OD can be assigned to a highway or transit route. The sum of the results for each segment of the system result is a forecast of the average daily or peak hour traffic volumes that will occur on the urban transportation system that serves the study area. To carry out a trip assignment, the following data are required. 1. Number of trips that will be made from one zone to another. This information was determined in the trip distribution phase. 2. Available highway or transit routes between zone. 3. How long it will take to travel on each route. 4. A decision rule that explain how motorists and transit users select a route. 5. External trips that were not considered in the previous trip generation and distribution step. Basic approaches. 3 basic approaches can be used for traffic assignment purposes. 1. Diversion curves. 2. Minimum time path assignment. 3. Minimum time path with capacity restraint. Diversion curves. This method is similar in approach to a mode choice curve. The traffic between two routes is determined as a function of relative travel time or cost. Minimum path algorithm. The traffic assignment process is illustrated using the minimum path algorithm. This method is selected because it is commonly used, generally produce accurate results, and adequately demonstrate the basic principles involved. The minimum time path method assigns all trips to those links that compress the shortest time path between the two zones.
Okay, ako po reporter nyo ngayon. Capacity restraint. A modification of the process just described is known as capacity restraint. The number of trips assigned to each link is compared with the capacity of the link to determine the extent to which link travel times have been increased by the additional volume placed on the formerly empty link. Okay. A reassigned is then made based on the new values. The iteration process continues until a balance is achieved, such as that the link travel time based on the loaded volume does not change with successive assignment. The speed-volume relationship, most commonly known used in computer programs, was developed by the U.S. Department of Transportation. It is called link performance function and expressed in the following formula. Yung formula po nasa baba ng sentence. Example, the volume on the link 1 to 5 was 485 and the travel time was 2 minutes. If the capacity of the link is 500, determine the link travel time should be used for the next traffic assignment iteration. Ito gagamitin maliit formula nakalagay doon. Yung T, yun yung travel time of the link. Yung T based to 0, yun yung pre-flow travel time. Yung V, o yung volume of the link. At yung C, capacity of the link. Okay. Total system cost assignment. Application of equation 12.12 in conjunction with capacity restraint, equation 12.13, will result in the equilibrium assignment where no single user may reduce their individual travel time by changing travel paths. However, user equilibrium assignment is not necessarily the method that results in the lowest travel time for all travelers. Rather, a total system cost assignment may be the option if the total cost as compared by the lowest individual cost is preferred. If a system cost assignment is used, route selection decisions are no longer made by the motorist but are the responsibility of the transportation agency. Kung di nyo po alam kung nasan nyo kung ano ang equation 12.12 o 12.13, makikita po ito sa module natin. Nasa chapter 12, page 600 something. To illustrate the potential benefits of the system cost assignment, considering a simple highway network shown in the figure 12.15, in this situation where there are two origin zone 1 and 2 and one destination zone 3, if 400 travelers desire to travel from zone 2 to zone 3, they have but one option: use link 23. If 300 travelers decide to travel from zone 1 to zone 2, they have two options: link 12 and link 23 in succession, or link 13 separately. So ba po yung example. An equilibrium assignment where each of the travelers from zone 1 to zone 2 individually chooses the fastest route, with the result in the total system cost of about 7,198 minutes as shown in the text. Only those traveling between zone 1 and zone 3 can reduce driving time by changing routes. Okay, nakita niyo na po sa graph. Ito yung mga result of equilibrium assignment of zone 3 highway network by link volume, link travel time, at link time between zone 1 and zone 2. Sa link 12, yung link volume niya ay 132.73. Yung link travel time naman niya ay 3.04, at yung link time between zone 1 to zone 2 ay 12.02. Sa link 23 naman ay ang link volume ay 532.73. Yung link travel time ay 8.98, at wala siyang link time between sa zone 1 at zone 2. Sa link 13 naman, yung link volume niya ay 167.27. Yung link travel time ay 12.02, at link travel time naman niya sa zone 1 at zone 2 ay 12.02. At yung total system cost naman nun ay katulad nga 7,198 minutes. Okay. Consider the situation where drivers must use a prescribed route. For example, all 300 motorists traveling from zone 1 to zone 3 would be told to use link 13. Under this scenario, the travel time for those motorists will increase slightly from 12.02 to 12.04 minutes. And the travel time to the motorists must be travel between zone 2 and travel to zone 3 will experience dramatically lowered travel times. The net result will be a lower system cost, as shown in the following table, where the total travel time has been reduced from 7,198 to 6,011 minutes. Okay, ito po yung yung table, yung lower system cost assignment. Yung sa link 12, sa link volume, wala, 0. Yung link travel time naman po niya ay 3. At yung link time between sa zone 1 at 2 ay 9. Sa 23 naman, link 23, 400. Link travel time naman ay 6. At yung link time between sa zone 1 at zone 2 ay wala talaga. Sa link 13, link volume naman ay 300, link travel time ay 12.02 tulad nga, at yung link time between zone 1 at zone 2 ay 12.02. Yung total system cost, tulad ng sinabi, bumaba ng 6,011. In general, the assumption of user equivalent assignment is a more realistic basic for depicting the individual decision making, since each travel acts on what they consider to be their own best interest. The lowest system cost assignment may be used of evaluating potential benefits of public intervention, such as traffic management strategies or improvements to infrastructure. For example, a public entity might choose to subsidize rail freight capacity if it found that total system cost for the rail and the adjacent interstate facility could be reduced, or variable message sign may direct motorists away from the congested area. Okay. The process of calculating the travel demand for an urban transportation system is now completed. The result of this work will be used to determine where improvements will be needed in the system to make economic evaluation of project priority, and to assist in geometric and pavement design phases. In actual practice, the calculations are carried out by the computer because the process becomes computationally more intensive as the number of zones increase.